Well, hello, tigers. Today, our I can statement is I can construct a linear function in slope-intercept form from a table of values, which really means that we're going to take a table of values and we're going to write an equation in slope-intercept form. So given our first example, we have inputs and outputs that are given. And I know that in order to write an equation, I have to have a couple of pieces of information. First of all, I know that an equation in slope-intercept form looks like y is equal to mx plus b. So I know to find the slope, it's going to be a change in my y's over a change in my x's. So I pulled a graph over here just so we could see what this would look like. If I was going to graph these points, I'll just do a few. 1, 6, and then 2, 8, and then 3, 10. I could easily see that my slope is up 2 over 1, up 2 over 1. But let's say I don't have a graph, then we can just do this mathematically. So the change in my output, that's going to be a positive 2, a positive 2. You can see where this is going. So that's going to be on the top. So my change in my y's is 2. And then I still have to, even though it's only 1, we still have to consider the change in our inputs or in our x's. So that's going to give me 2 over 1. So in other words, our slope is m is equal to 2. So I'm going to go ahead and substitute in 2 to the equation, and then I just have to choose 2 points from my input-output. I'm just going to choose 412, and then I'm going to go ahead and substitute that in. So I know that x is my input and y is my output. So my x value is going to be 4, so that's 2 times 4. I don't know b. I have to find b. That's why we're doing this. And then I'm going to substitute in 12 for y. So we end up with 12 is equal to 8 plus b. When I subtract 8 from both sides, then of course I end up with 4, or b is equal to 4. Once I know my b, then I can go back and substitute it into the equation. So my final equation then is y is equal to 2x plus 4. Let's see if that checks. So let's go back, and if I input 1 into the equation, I have 2 times 1 plus 4, and looky here, it equals 6. Let's just take another one. Let's take 3, and let's say 2 times 3, which is 6, plus 4, and out comes 10. We did a good job. Moving on to our next example. So I need to find the change in my input, and I need to find the change in my output. You can always take the second value and subtract the first. So I'm going to take -3 and I'm going to subtract -5. That is going to give me a change of -3 plus 5. That's going to give me a positive 2. So from -5 to -3, then I have a positive 2. Notice that we kind of skip some numbers here. So the difference here between -3 and positive 1, that's going to be a 4. And then here, look, I'm back to positive 2, and I'm back to positive 2. So that's why it's important for you to find it's going to be the change in the x's over the change in the y's, because sometimes numbers are skipped. And for example, we've kind of skipped something in between here. So we missed an output. The change in my input is going to be positive 3. I added 3. Here, though, look what happens. I add 6, add 3, and then add 3 again. So as far as the formula is concerned, it's still going to be m is equal to the change in my y's, not y, but the change in my y's. I showed you on the last problem on the graph, the change in the y's over the change in the x's. So we end up with then, let me take this 4 and let's take the 6, and we'll see if that changes if I were to choose a different set of changes. So I'm going to take my output, which would be y or 4, and then my input, which would be 6, and look at that, it's going to simplify down to 2/3. And as you can see, That's going to be exactly what it would have been had I chosen the other changes. So we can always check our work to see if it's consistent throughout. Once I know M, then I want to plug into my equation. Write your equation first. Y, well, we have to choose one, but I know that M is 2/3. And then I'm going to go over here and I'm just going to choose values. Let's see. I'm going to choose this time. I'm going to choose 9 and 5. Why not? I know that this is my X because input is X, and then the 5 will be my Y. So I'll substitute in 9 here. I don't know B. That's what I'm trying to find. That's the purpose of substituting in X and Y, is to find our Y-intercept or our B. And then our output is 5. So 5 is equal to 3, 6 plus B. When I subtract 6, I end up with -1 is equal to B, or B equals -1. Now that I know the equation, or now that I know the y-intercept, I can go back and substitute it in. The purpose of this was to write the equation. And then once again, we can check our work. I'm going to choose 3, 1 to check. So when I do that, I have 2/3 times 3 minus 1. And look here, 2 minus 1, that equals 1. So the function rule serves a purpose. It should match your table. Your input, put in for X, and then output should be your Y. You can go ahead and try this example on your own. And when you're finished, you can go ahead and start up the video. Make this a 21. Alrighty, so now I need the change in my Y's over the change in my X's. So I'm going to just choose, let's do 6 and 18. This is the change here. So we have 6 over 18, which simplifies down to 1/3. So that'll give me my M. Y is equal to mx plus b. Substitute in M, which is 1/3. And then I'm just going to choose some values. I think I will choose, what do I want? Let's do 57 and 20. Once I know my M and I know my B, then I can go back and put it into the equation. Y is equal to mx plus b. So y is equal to 1/3 x plus 1. And then, of course, you could choose a value to check. I'm just going to go ahead and check with 3, 2. So when I put in 3, 1/3 times 3 plus 1, 1 plus 1 equals 2. Check. We did an awesome job. I hope you enjoyed your lesson on writing an equation from a table of values.